We like to believe we know our world, but tucked away in the forgotten corners of our map are places that should not exist. Landscapes so hostile, so alien, they feel like fragments of a distant, dying star. Here, the ground doesn't just breathe, it screams. The water doesn't bring life, it dissolves it. You are about to enter a realm where the rules of biology are suspended, where the air is poison and the earth is a liquid fire. Starting with a place where the air itself becomes your enemy. Dallol. Dallol, a kaleidoscopic nightmare at the edge of the known world. It is the hottest inhabited place on the planet. But inhabited is a relative term. Sitting at nearly 100 meters below sea level, in the lowest and most torrid corner of the Danakil Depression, Dallol does not so much greet visitors as repel them. Here, the average temperature sits at 94 degrees Fahrenheit, not as a peak, but as a constant. Below the surface, a subterranean volcano rages, forcing boiling brine and acidic magma through a labyrinth of salt. What you see isn't water. It is a toxic cocktail of sulfuric acid and iron oxide. A liquid so caustic it would melt the skin from your bones in minutes. It is a landscape of impossible colors, electric yellows, violent oranges, and lethal greens, all created by a chemistry that mocks the very idea of life. The moment you step onto its surface, the heat seizes you. Not the warm embrace of a summer afternoon, but something clinical. Absolute, the heat of a planet in revolt. The air carries the acrid, throat-sealing stench of hydrogen sulfide and sulfur dioxide. A chemical cocktail that, in sufficient concentration, transforms the human lung from an organ of survival into a liability. An obstacle that simply ceases to function. Chlorine, carbon dioxide. This is an atmospheric ghost. A collection of volcanic gases older than multicellular life itself. The ground itself is a mosaic of mineralized crusts. Salt flowers, sulfur chimneys, and pools of liquid so acidic they register a pH close to 0. The most corrosive natural environment ever recorded on this planet. Geologically, Dallol defies expectation at every level. Beneath your feet, 3 tectonic plates are being slowly, violently torn apart. The African plate, the Arabian plate, the Somali plate, they are separating at a rate of 2 centimeters per year. And in their separation, they are generating hydrothermal systems of extraordinary kaleidoscopic intensity. The result is a landscape that scientists openly describe as the closest terrestrial analog to the surface of Jupiter's moon Io, the most volcanically active body in the solar system. In 2019, researchers confirmed something that had long been suspected. The hyperacidic pools of Dallol contain no microbial life whatsoever, not even extremophiles. Organisms that thrive in the harshest conditions on Earth can survive here. Dallol is officially a dead zone, Earth's own barren moon. Humans can survive in Dallol for minutes, perhaps less. Dallol does not merely challenge life. It erases the very concept of it. On the Reykjanes Peninsula in southwestern Iceland, there's a window directly into the Earth's interior. Fagradalsfjall, a volcanic system that had been dormant for 800 years, woke up in March 2021. A slow, deliberate exhalation. A fissure opening in the Earth and simply pouring. It has not stopped since. The Fagradalsfjall Valley sits within the Reykjanes volcanic belt, a direct surface expression of the Mid-Atlantic Ridge, where the North American and Eurasian tectonic plates are being pulled apart at a rate of approximately 2.5 centimeters per year. The peninsula is, in geological terms, a seam, a suture, the place where two pieces of the planet's crust are separating and the molten interior is filling the gap. Walking toward the eruption site, you first notice the smell. Not the sharp sulfur of a fumarole, but something deeper, older, the metallic, mineral scent of fresh basalt. The smell of new earth. Earth that did not exist yesterday. Then the heat reaches you, radiant, insistent. Not the heat of a summer afternoon, but the heat of something operating at 1200 degrees Celsius, indifferent to your presence. And then you see it, lava. Moving lava, flowing in slow, incandescent rivers of orange and black. Its surface crusting and cracking as it moved forward, revealing the blinding interior beneath. The sound it makes is unlike anything in ordinary experience. A low, rhythmic crackling, mixed with sudden explosive pops as gas pockets rupture in the cooling crust. It sounds unmistakably alive. What makes Fagradalsfjall scientifically extraordinary is the directness of its magmatic source. Analysis of the erupted lava reveals that it originates from the Earth's mantle itself, from depths of 15 to 20 kilometers, with minimal contamination from the overlying crust. This is primordial material, some of the most unprocessed rock ever to reach the surface of Iceland. Geochemists describe it, without exaggeration, as a window directly into the Earth's interior. The lava flows of Fagradalsfjall advance at walking pace. They incinerate everything they contact: vegetation, soil, infrastructure. And they do not stop. They do not turn. They do not negotiate. Geophysicists believe the current period of activity may continue for decades or centuries. This is the only major city on Earth built directly on top of an active geothermal field. Not near, not adjacent, on top. Rotorua. In here, the smell reaches you on the plane's final approach. Sulfur, earthy and inescapable, permeating the air above the airport. Locals call it the Rotorua perfume. They are accustomed to it. You might not. From the air, the city looks like any mid-sized New Zealand town. Suburban streets, a lake, parks, school ovals. But look at the spaces between the buildings. Steam rises through drains, through garden soil, through cracks in the asphalt. The entire city exhales, continuously, without pause, as though the ground beneath is breathing. It is. The Taupo volcanic zone, the geothermal and volcanic system beneath Rotorua, is one of the most geologically productive regions on Earth. It runs for 250 kilometers across the North Island, driven by the subduction of the Pacific Plate beneath the Australian Plate at a rate of roughly 5 centimeters per year. The friction of that subduction generates vast quantities of heat. That heat finds its way upward through the crust, through fractured volcanic rock, through the foundations of a city of 80,000 people. And then there is Waiatapu, the region's most visually arresting thermal area. The Champagne Pool reaches 62 degrees Celsius and exhales carbon dioxide in a continuous, slow effervescence. Its edges are encrusted with arsenic, antimony, and gold. Actual gold, precipitated from hydrothermal solution and deposited in delicate yellow films along the pool's orange shoreline. The ground around it is a geological jeweler's window, one that will dissolve you on contact. The Devil's Bath nearby holds water of a color that should not exist outside of a chemist's laboratory. A flat, opaque chartreuse produced by the interaction of sulfur and ferrous salts in solution. No filter, no manipulation, just chemistry at the surface of the earth, making a color that has no precedent in nature. The Lady Knox geyser erupts every morning at precisely 10:15. Not through geological punctuality, but because park rangers add soap powder to the vent, disrupting the surface tension of the superheated water and triggering eruption on schedule. Even here, humans have found ways to timetable the planet. The Taupo eruption, approximately 1,800 years ago, was the most violent volcanic event on Earth in the last 5,000 years. Its pyroclastic flows incinerated the central North Island. Its ash cloud reached the stratosphere. Roman and Chinese historians, 12,000 kilometers away, recorded unusual red sunsets in the year 232 AD without knowing why. Beneath Rotorua, that same system remains pressurized, active, evolving. New vents open beneath homes without warning. Existing vents enlarge, destabilizing foundations. Carbon dioxide accumulates in basement spaces, displacing oxygen with silent efficiency. The city's relationship with its geological substrate is not one of mastery. It is not even one of management. It is at best coexistence, fragile, contingent, and conducted entirely on the volcano's terms. In the darkness before dawn, on the eastern tip of Java, Indonesia, a color appears that has no precedent in ordinary nature. Blue fire. Not metaphor, not geological shorthand. Actual, burning, electric blue flames. Erupting from the flanks of Kawah Ijen's volcanic crater and flowing down the mountainside in rivers of cerulean light. The phenomenon is caused by igniting sulfuric gas, hydrogen sulfide, venting from the crater at temperatures exceeding 600 degrees Celsius, combusting on contact with atmospheric oxygen. The resulting flames burn blue, not the conventional orange of organic combustion. The crater lake of Kawah Ijen holds one of the largest natural deposits of sulfuric acid on Earth, a turquoise pool of extraordinary, murderous beauty. its pH hovering near zero. It is, volumetrically, the most acidic lake in the world. The air around the crater is saturated with sulfur dioxide. The smell is not just unpleasant, it is a physiological assault. Eyes burning, lungs seizing, the body's every instinct screaming retreat. Kawah Ijen sits at the intersection of the Sunda Arc, a subduction zone where the Indo-Australian plate dives beneath the Eurasian plate with geological violence. The magmatic system beneath the crater has been continuously active for millennia. The blue fire is only visible at night. In daylight, the flames become invisible, the same combustion continuing, unseen, against the bright sky. The mountain shows its secrets only in darkness. Despite all of this, despite the acid, the toxic air, the blue fire, human beings descend into the crater of Kawah Ijen every single night. Sulfur miners, carrying baskets of solidified sulfur on their backs. Loads of up to 90 kilograms, hauled up the crater walls in darkness. Wearing, at best, cloth rags over their faces as respiratory protection. The average life expectancy of a Kawah Ijen sulfur miner is 40 years. The human cost of this landscape is not geological. It is human, quiet, devastating. Beppu, on the island of Kyushu, is where that physics reaches the surface with theatrical extravagance. Japan sits at the intersection of 4 tectonic plates. The city produces more geothermal steam than almost anywhere else on the planet. But it is the Jigaku, the hells, that command attention. 9 geothermal pools, each with its own character, its own impossibility. Umi Jigaku, sea hell, a cobalt blue so vivid, so synthetically perfect that it reads as digitally enhanced. It is not. The color emerges from dissolved silica and the scattering of light through superheated water at 98 degrees Celsius. Chinook Jigaku, blood pond hell, a visceral, oxidized red, its surface bubbling with the slow, thick rhythm of something very near boiling. Iron oxides and clay minerals, leaching from the volcanic substrate, turn the water the color of arterial hemorrhage. Beppu sits directly above a magmatic system associated with the Aso caldera, one of the world's largest active volcanic systems, capable of eruptions that have historically altered the regional climate. The Jigaku pools each tap into different levels and chemistry of the hydrothermal system. Different temperatures, different mineral compositions, different gases. They are, in effect, windows into separate layers of the same geological machine. The hells are enclosed, managed, observed, but the geothermal field beneath Beppu does not respect enclosures. Hverir, on the shores of Lake Mývatn in Iceland's north, is where that scene becomes a spectacle. The Mid-Atlantic Ridge, the boundary between the North American and Eurasian plates, runs directly through the island. Geologically speaking, it is the seam of the world, held together by nothing but continuous volcanic output. The mud pots of Hverir, called solfataras, are gray-brown cauldrons of boiling, sulfur-saturated clay, churning with the slow, deliberate rhythm of something supremely indifferent. They smell of rotten eggs, of deep earth, of hydrogen sulfate emanating from magma chambers not far below. The ground between the fumaroles is hot to the touch, ochre and rust and sulfur yellow, the palette of oxidation and heat. Steam vents roar with a sound that vibrates in the chest, a frequency more felt than heard. Beneath Hverir, a shallow magma body drives the hydrothermal activity. Groundwater percolating down through the fracture basalt encounters this heat and returns to the surface, chemically transformed. Enriched with sulfur, carbon dioxide, and hydrogen sulfate. The mud pots form where this acidic steam dissolves the surrounding rock, turning solid basalt into liquid clay. The earth, quite literally, eating itself from within. The thin crust over the boiling mud is one of the primary hazards. It looks solid. It is not. The pale, dried clay surface conceals liquid mud beneath, hot enough to cause severe burns instantaneously. Iceland manages Hverir with boardwalks and barriers, but the boardwalks end, and beyond them, the landscape does not negotiate. Beneath the forests and meadows and bison-grazed plains of Yellowstone National Park, there is a magma chamber the size of a small ocean. It contains enough molten rock and superheated gas to alter the climate of the entire northern hemisphere if fully erupted. Yellowstone is a supervolcano, one of fewer than 20 known on Earth. Its last full caldera-forming eruption, 630,000 years ago, deposited ash across half of North America. The Grand Prismatic Spring is the crown jewel in the park. It is 530 meters long. Its color transitions from deep blue at the scorching, sterile center to the vivid orange rings of thermophilic bacteria at its cooler margins. From altitude, it resembles a planet's eye. Then there's Old Faithful. As the namesake, a highly predictable geyser erupts, on average, every 91 minutes. A column of boiling water and steam reaching 21 meters, driven by a pressurized hydrothermal plumbing system of Baroque complexity. It has erupted more than 1 million times since records began. It will erupt again in roughly 91 minutes, whether you're watching or not. But if Old Faithful is the park's steady heartbeat, Steamboat Geyser is its erratic, violent fury. It is the tallest active geyser on Earth, capable of rocketing superheated water over 100 meters into the sky. Yet unlike its predictable neighbor, Steamboat is entirely lawless. It can lash out dozens of times a year, or vanish into deep, deceptive silence for a decade, leaving a roaring, days-long exhaust of pure steam when the water finally runs dry. The hydrothermal features of Yellowstone are, individually, immediately lethal. The water in the thermal pools reaches 230 degrees Celsius under pressure, far above the boiling point of water at altitude. Human contact is unsurvivable, but the deeper danger is not the pools. Yellowstone's earthquake swarms, thousands per year, are a constant reminder that the system beneath remains dynamic, pressurized, unresolved. The question volcanologists are routinely asked about Yellowstone is not if, it is when. Russia's Kamchatka Peninsula is one of the most volcanically active regions on the planet. And in a remote, deeply incised canyon within this volcanic wilderness, accessible only by helicopter, lies the Valley of Geysers. Discovered only in 1941, more than 90 geysers, thermal springs, mud pots, fumaroles, confined within a canyon 4 kilometers long and barely 200 meters wide. The highest concentration of active geysers in Eurasia. That the geothermally heated ground does not freeze. That the grass around the springs remains green when everything else is buried in snow. In 2007, a massive landslide buried a third of the valley's geysers under mud and debris. A temporary lake formed. The world mourned the apparent loss. Within 2 years, most of the buried geysers had cleared their conduits and resumed erupting. The water found new paths. The valley reasserted itself. The valley is closed to unguided access. Helicopter approach only. Unstable volcanic soil. The ever-present threat of further landslide. At 4,320 meters above sea level, in the Atacama, the driest non-polar desert on Earth, there is water. Impossible water, erupting water, water boiling in a landscape where the air is so thin that it boils at barely 86 degrees Celsius. El Tatio, the grandfather who cries. The air is biting, minus 10 degrees Celsius before sunrise. And yet the ground erupts. Steam columns rise 30 meters into the thin Andean air, driven by water at subcritical temperatures, superheated, but boiling at a lower point due to altitude. The droplets freeze almost immediately at the plume's edges, creating halos of ice crystals around columns of scalding water, hot and frozen in the same cubic meter of air. The desert contains multitudes. El Tatio sits within the central volcanic zone of the Andes, a chain of volcanoes produced by the subduction of the Nazca Plate beneath the South American Plate. The magmatic system here is vast, complex, and geologically recent. The water erupting here has been in contact with active magma. It carries its memory. The combination of altitude, where oxygen deprivation impairs judgment, with the extraordinary visual spectacle creates conditions where human risk assessment becomes unreliable. The most beautiful moments of El Tatio are the most dangerous. Dawn, when the steam columns are at their most dramatic and the geysers at their most active. Between 1730 and 1736, a series of volcanic eruptions on the island of Lanzarote lasted for 6 continuous years. 6 years. During this period, lava flows buried over 200 square kilometers of the island's most fertile agricultural land, a quarter of Lanzarote's total area, under 20 meters of basalt. 11 villages disappeared. The landscape was transformed absolutely, irrevocably. What remains is Timanfaya, now a national park in Canary Islands in Spain. Now protected, now one of the most extraordinarily barren and beautiful landscapes in Europe. At the center of the park, the Islote de Hilario, a parking lot atop a thermal anomaly so powerful that dry grass bursts into flame when pushed into a hole in the ground. Water poured into a pipe emerges as steam within seconds. The ground temperature 50 centimeters below the surface, 600 degrees Celsius. Timanfaya is not extinct, it is patient. The Canary Islands sit above a mantle plume, a column of anomalously hot material rising from the deep mantle, similar to the hot spot beneath Hawaii. The islands are not at a plate boundary. They're in the middle of the African plate, punched through from below. Timanfaya's volcanic system is considered capable of renewed eruption with minimal warning. The geological memory of the island is long. This is not its first eruption, and it will not be its last. And still, the chef grills meat over a volcanic vent, and tourists eat their lunch, and the 600-degree ground beneath them holds its temperature, steady and patient for another day. We call these places dead zones, hostile environments, extreme, but they are not extreme. They are original. They are what Earth looked like before we arrived. They are what it will look like after we are gone. We are the guests here. We have always been the guests. And Earth, patient, primordial, indifferent, has always known it.